Practice question set number 9. Question number 1 says, Newton's law of universal gravitation has a mathematical relationship similar to the one developed by who? Gravitation, that was physics 20, right? We're talking about a physics 31 now. What one sounds, looks, reminds us of Newton's law of universal gravitation, physics 20? Yep. Yeah, it's Coulomb's law, right? The gravitational law is F is equal to G m1 m2 over r squared, whereas the Coulomb's law is F is equal to K Q1 Q2 over r squared. So the relationship is very similar. Now, we know the answer to that question, right? But in the absence of knowing the answer, we can actually eliminate all 3 of the other possibilities. And here's how. You can trust me on this. This is up to and including your diploma exam at the end of June. If you haven't learned about it, it's not the answer. Okay, remember that. If you have not learned about it, it's not the answer. We will have, by the end of the year, learned about Einstein and Lenz. So those names you will recognize by the end of the year, and they would be, therefore, possibilities. They're not the correct answer for this question, but they would be possibilities by the end of the year. That last one, Ohm, we don't even learn about that in physics 20. Trust me, sorry, in physics 30. Trust me, if you haven't learned about it, it's not the answer. To this point, I wouldn't give you a question where the answer was B, C, or D if we haven't learned about those names. So remember that. Sometimes people see a question and they say, oh, I don't recognize that. That must be the answer. Okay? That's the exact opposite logic you should use. If you don't recognize that, then you should not pick that as your answer because it can't be right. All right, 2. Which of the following graphs represents the relationship that Coulomb determined between force and distance between the 2 charged spheres? What's the answer, A, B, C, or D? Sometimes the answer is D, yeah. Sometimes we get a question like this. The easiest way to tackle is to write down the equation. We know the equation is KQ1 Q2 over R squared. If we're looking for the relationship between F and Q1, we say that's a linear relationship. So the answer would be C for that. F and Q2, same thing. But F and R, we know that's an inverse square relationship, so the answer is for sure D for that. Now, if we wanted to straighten that graph, if we wanted to turn it into a straight line graph, how would we do that? How would we turn that into a straight line graph? F versus what? F versus R clearly gives me an inverse square relationship. Connor? Sorry? The inverse goes into... Okay. The inverse of the inverse? Okay, good idea, but doesn't quite work.
Isn't that what we did on the lab?
No, not the inverse of the inverse. Because then we'd just be plotting F versus R, right? How about this? The inverse of the square. That's what you meant?
That's what it's on the graph. I was trying to remember
What if we wanted to straighten out this one? Like, this is wrong, right? This is the wrong relationship. It's not an increasing relationship like this. But if we wanted to straighten out this one, let's say this was the correct relationship. How would we turn that one into a straight line? It wouldn't be F versus 1 over R squared. Rather, it would be F versus R squared, not 1 over R squared, right? That make sense? All right. Next question, number 3. Is the magnitude of the electric force on an alpha particle that's 4 times 10 to the negative 10 meters from an electron is what? Well, this is a straightforward Coulomb's law question where we just say F is equal to KQ1 Q2 over R squared. We've got to recognize what the charges are here, but they're on our data sheet. We got 8.99 times 10 to the 9 for our value of K. The charge of the electron is 1.6 times 10 to the minus 19. And the charge of the alpha particle, on your data sheet, it says 2e. What's an E? What does E stand for, Zach? Yeah, when we say the charge of an alpha particle is plus 2e, what does the E stand for? Yeah, the elementary charge. And the elementary charge is a value of, 1.60 times 10 to the minus 19 coulombs. So that means 2 times that is 3.2 times 10 to the minus 19 coulombs. Okay, we divide that by R, which is 4 times 10 to the negative 10 squared. I want to go through the math on this. I think I mentioned this little thing the other day, but some of you still seem to be doing this the wrong way. in terms of entering it into calculator. Don't use that silly times 10 to the whatever, right? Don't say 8.99 times 10 to the 9. Don't do it that way. As a numerator, that actually works. But we don't want to do it that way because it doesn't work as a denominator. So what I want you to do is, I want you to enter it the right way. 8.99, second function, EE, 9. That way it attaches the exponent and the power, the 10 to the whatever, to the 8.99. Now on the top it doesn't really matter, but on the bottom it becomes a bigger deal. 1.6 EE negative 19, 3.2 EE negative 19. Then we can divide that by, no, all we have to do is say 4 EE negative 10, and we square that. 4 EE negative 10, square that, and we get a value here of 2.9 times 10 to the minus 9. And the answer for that one is, D. Okay, how many people are doing the EE thing now? Okay, don't do the times 10 to the whatever thing. Okay, do the EE thing. Finally, number 4. We saw this question on Friday, actually. That's okay. Coulomb started with 2 identically charged spheres separated by distance r. The force between the spheres was F. He changed the separation distance to 2/3 r. What's the force become now? This is my original force, FO, is equal to K Q1 Q2 over r squared. This is what it was before I made any changes to it. Now it's time for my changes. Now I'm going to say Fn, F new, is my new force, after I make my changes, is equal to K. It didn't change K, didn't change Q1, didn't change Q2, over, what's r become? It's not r anymore, it's 2/3 r, right? Now, be careful here. This is a very common mistake. It's not 2/3 r squared. It's 2/3, in brackets, r squared. How come? Well, we're not squaring r. Like even in the top equation, we're not squaring r per se. We're squaring the distance that separates them. The distance we represented by r. Now we're representing the distance by 2/3 r. If the distance was r, the distance is now 2/3 r. You got to square the distance, not the r. So it becomes 2/3 squared, r squared. Now if you square 2/3, to pull it outside of the brackets, you get 4/9. Now how do you divide by a fraction? How do you divide by 4/9? You guys know this, right? Know this from math class? Yeah, right? Yeah, multiply by the reciprocal. So KQ1, Q2 over 4/9 is the same as 9 over 4 times KQ1, Q2 over r squared. So this is my original force. So it becomes 9 over 4 times my original force, meaning the answer is going to be D for that one. A pretty common answer for this would be C. Pretty common answer would be C because a lot of people tend to forget to square the 2/3 there. Right? And that's assuming you multiply by the reciprocal. If you forget to square it and forget to multiply by the reciprocal, then you're going to get B. And if you forget to just multiply by the reciprocal, you get, go figure. All these common mistakes that people make, they're there. They're there. Okay, that's not dirty. All they're doing is saying, look, if there was no options listed there, if this was just fill in the blank, and you got 4 over 9, well, then that's what you'd write down, right? They're not trying to trick you. They're just trying to not give you credit when, not trying to tell you you have a wrong answer necessarily.